Okay, let's look at the first process model. So this is the waterfall model. So waterfall model is a very conventional model, and it can be considered as obsolete right now because people don't actually build software using this notion anymore. So as you can observe in the waterfall model, it has the linear or sequential order, okay, which means that if we adopt the waterfall model, that means we have to follow the steps in this order, okay. And as we know, the weakness is that you cannot go back to fix any error until you finish the full cycle. So in one situation that the waterfall model is suitable to be used, okay, what do you think? The second model is the V model. So the V model starts from here and moves to the up. Okay, the idea is to have the framework activities, and at the same time they are assigned with the respective testing activities. For example, here during requirements modeling, we prepared the models and so on, and it has dedicated testing for the specific activity. So the idea is that all the activities has its pair set of testing activities. Okay, now in what kind of situation that is suitable to use V model? Especially those systems who need to be verified, okay. So the drawbacks, perhaps you have to add more effort on testing because of the model. The third one is incremental models. So in incremental models, you can see that it has the although it is not drawn as what you have seen in the previous lecture, but it's actually have the elements of increment. Okay, so the whole system are divided into a few increments. Okay, so that each of the increment has the same set of activities, which are the framework activities, okay, communication, planning, modeling, construction, and deployment. So in the end of each increment step, so the first increment will be produced, and then the following increment, we will execute the same series of activities until the final increment. In the end, the final delivery of the increment. So what kind of situation that is mostly suitable to use incremental model? Okay, when you want to organize a big system into smaller partitions, and the user might want to see the progress by increments. Okay, so this is the right model to use. Evolutionary models, okay, it has been designed to accommodate software that is expected to change rapidly. Okay, that means keep on changing. Okay, and it has this iterative nature. Okay, so that it allows the developer to develop an increasingly more complete versions. That means first you come up with the first version, then the next version, and so on. So these versions are actually complete, not as in the incremental model. In the incremental, you might have different parts of the software that are being designed and developed, but for evolutionary models, they are the whole complete system, but they are developed in a much more refined manner. Okay, one example of process model for evolutionary model is prototyping. Okay, now prototyping is an example of process model. Evolutionary model is the category. So in this example, you have communication, you quickly design, and then you develop the prototype, get feedback, then you further develop, get the communication from the stakeholders, and further develop it to make it much more complete. Okay, so you may come out with a better version than your first version and so on. Okay, but you're not talking about increments. Okay, so the spiral. is also evolutionary model. So you start from here. So you start with communication, planning, modeling, construction, deployment. You get the feedback, then you further communicate, and you further iterate in a spiral manner. Okay, so the idea is also working on the whole complete system rather than increment. And the complete representation of the spiral model is that for all these division, actually they have risk assessment. So this is one of the significant property of a spiral model. Okay, like this one, you can see that they have risk analysis for each of the cycle. So if you are to use spiral model, that means you need to further study on the risk analysis part. Okay. So concurrent model. So this can be you see, when I use concurrent models, that means this is a category. Okay, so an example that you can see is being represented in this figure, which is not really representing the real software development activity. So this is actually to represent the state of a software engineering activity. It is not the whole complete system like the other examples. Okay, so it defines series of events that will trigger transitions from one state to another, from one state, okay, from under development to a waiting stage. What makes it change from one state to another state? But I put a note here that it is not suitable for your project. Why? Okay, because this example is not actually showing the what are being concurrently executed, okay, which is not suitable. So other than all the conventional process models, okay, we also have specialized process model for component-based development. In this component-based development, their focus is not similar like when you want to develop system from scratch. So they have different kind of models to represent their software process. Okay, same goes to formal methods. So formal methods emphasizes mathematical specification for requirements. Instead of representing requirements in natural language or in terms of model driven, they use mathematical specification. So this is important for complex system where you cannot allow if there is any incorrect behavior. The third one is aspect oriented. So this one is more about quality requirements. Okay, aspects like security or availability or reliability. So this is more not very directly related to your course. And the next one, we have unified process. So this one is based on use case driven, which is relevant to us, and it has architecture centric in terms of its design. It is iterative and incremental in manner. That means they combine iteration and incremental in representing their process model, and they are using unified modeling language as a representation. So the unified process, so you can see that there is a notion of increments being produced. That means it is incremental by nature. At the same time, it also have the iteration process. Okay, unified process has also communication, planning, modeling, construction, and deployment. At the same time, they have these phases which they call as inception, elaboration, construction, and transition. So I think we have another figure to represent that. Okay, so they call this as phases. Okay, so they have phases and they have workflows. Okay, so you can see the workflows are similar to the framework activities, and they have the phases. Okay, what you can observe here is that, is there any arrow to represent the order? So how do you know which one is executed first? Okay, This is another representation of the unified process. Okay, it's the same representation, but in a slightly different manner. So you can see the faces, okay, and they have iterations, okay, and they did not use any arrows, okay. So this one is based on time, okay, in this axis, okay, and this y-axis is for disciplines or for the workflow. So what does these shapes represent? Okay, so it's actually representing effort. Okay, you can see at the beginning, okay, some of these activities are done in parallel but with different emphasis. Okay, for example, in the beginning, the business modeling being done, executed, okay, and the follow up by requirements, but at the same time they also started with testing, okay, but the effort is very minimal, okay. So that means some of the activities can be done in parallel. So these are some of the work products. That means what are the recommended outcome from unified process. So during each phases. Example here, let's say in construction, they produce design models, software components, integrated software increments, test plan, test cases, and user manuals, and many more. Okay, so this is what software process model prescribed for us. And finally, we have the personal and team process models. So this is a bit different in the sense that instead of focusing on the process, they focus more on person involved in the development team. In this example, the personal software process is a guideline for each team member for planning, to have design, to have review, development, and also postmortem. Okay, so example here in planning, it isolates requirements and develops both size and resource estimation. They come up with estimation, and they have metrics recorded for all the items. Okay, finally, the development tasks are identified and a project schedule is created. So for each of these processes, they focus on how each person will be able to achieve the task. Okay, and as compared to the personal team process, the personal software process, the team software process now is talking about planning or tracking as a team rather than having a personal point of view. Okay, so this can also be used to motivate and also to coach the team members, okay, to maintain their performance. Okay, and later on you will see that this characteristics is one of the key process area in capability maturity model. So we will cover this chapter later. Okay, and finally, the exercise for this topic is that I want each group, okay, first please make sure that you have registered. Okay, I want each group to find a software process model based on the information that you have learned from this video. Okay, from this video lecture. Find one process model example. When I say example, that means they must be a specific name of the process model from any of the category. Okay, find a figure to show, to visualize the process model. Okay, I've put a template for the answer. You can refer to the Padlet here. I also provided the link to this in iTalim. Okay, and I want you to avoid examples given in the class. You can find other variances of the model. They may look similar, but they have other feature than the one that I've shown in the lectures. Okay, and all submissions must be unique. That means first come, first serve basis. And this is a group activity. Okay, all the best, and see you in the next lecture. Assalamualaikum and thank you.